Hello, baby. Yeah, this is the Big Bopper speaking. The aim of today's experiment is to determine the influence of various environmental factors on the rate of transpiration by means of a potometer. Now, if you look at this apparatus, you'll see this is a potometer. We have a flat bottom flask here, and then we have a rubber stopper with two holes in it, and then a syringe, and then a capillary tube. Now you might wonder what a capillary tube is. I'm going to show you. A capillary tube is a glass tube with a very thick wall, yeah, and a very thin hole in there. So we want to establish the rate of transpiration very accurately, and that's why we need such a small hole in the glass tube. So what I do is I'm going to determine the influence of various environmental factors on the rate of transpiration. And factors like the effect of a very dry, hot wind, or maybe an increase in humidity around the plant, or maybe even the influence of increased light intensity. But first of all, I'm going to show you how you use this pruner to cut a little branch of a blue gum tree. I found that the blue gum tree is the best tree to do this experiment with. So what I do is I look at the hole there, and I just judge it here, more or less the size of the hole, and then I cut the branch there, and then very slowly I push this branch into this hole of the rubber stopper, and there you can see I've got it. So I've already done it with this setup. So I'm going to show you what happens. If you look at if I press the syringe, you might be able to see the small tiny air bubble in there. And I'm very interested in the movement of that air bubble. Can you see it move? There. Now, to determine the rate of transpiration, I first have to discuss or explain what transpiration is. So transpiration is the loss of water vapor by the leaves and the stems of the plant. And I have a model of a cross-section of a leaf here. Here you can see the upper epidermis, the lower epidermis, and there I have the stoma. And then I have the intercellular spaces here. So what happens is, water evaporate from these parenchyma cells into this intercellular spaces, and then it's released through the stoma there. Now that water that evaporated need to be replaced, and we have the xylem here, which is tubes that can suck. It can transport water from the roots to the stems of the plant. Now you can see my air bubble has moved beyond the first mark on my capillary tube, and I need a stopwatch to do this. And I'm going to use my cell phone stopwatch for this. And the moment the air bubble touches the first mark on the capillary tube, I press the start button. And you can see it's moving rather rapidly there. So rate is always concerned with movement in a specific time. So you can see that's why I've made the two little marks on the capillary tube, namely to establish how quickly the air bubble moves between the two marks. And they reached the second mark, and I press stop, and you can see it took 34.02 seconds to move from one mark to the other. So it's 34.02 seconds. That's the first measurement. Now I push the air bubble back, and then I wait for it to start moving again. Can you see how sensitive the plant is? The slightest movement whatsoever has an effect on the movement of the bubble. So there it's now moving back to the first mark, and I can discuss the other factors that we're going to use. I've mentioned the effect of light intensity and we measure the effect of light intensity with an electric light. So to increase the light, I'm using the light to record this, but under normal circumstances you won't have the light on while you're doing the normal measurements. So now you see it's back to the first bubble, and then I reset and I press start again, and there, yeah, you see I've leaned a bit forward, so I have to stop it, reset it, and start the measurement again. And now it's moving nicely. If we want to create humid conditions for this experiment, we take a plastic bag and then put it over the plant and attach it to the stem of the plant with a tiny rubber band. So in that way the plant's leaves, when it releases the water vapor, cannot. And then my second measurement is like 42.06 seconds, and now you can see I've got two of these and they differ slightly, or quite obviously, but I'll take the third one and then I calculate the mean of the three measurements, and in that way I get a more accurate indication of the rate of transpiration. So I've talked about increased humidity with the plastic bag, and then a warm dry wind, which I can create by using a hairdryer on warm or a heater, and then the effect of wind I just use like a fan or a hairdryer on cold, and there I can create the 3 or 4 different environmental factors that might have an effect. In each case I would have an hypothesis. In the if-then, I formulate in the form of the if-then formula, and then it's an intelligent guess that I take. If my hypothesis in the case of the humid conditions would be, if I increase the humidity around a plant, then the rate of transpiration might be slower, and then I'll do the whole experiment with the plastic bag, and then in the end, after I've taken all the measurements, then I'd come to a conclusion. I'd accept or reject the hypothesis. There's also always dependent and independent variables in the case of an experiment, and in the case of this experiment we talk about the effect of wind and humidity and so on. Those are the independent variables, and I keep them stable, and then I take the measurements and I say, what's the effect of humidity, which is the independent variable, on the rate of transpiration, which would then be the dependent variable. And that's the way I do my experiments, always in that formula. Or I might also formulate an operational question, and the question might be something like, what would the effect of different abiotic or environmental factors be on the rate of transpiration? So you see, if you set it up airtight, there my bubble is still moving, and it's really hugely exciting to see the movement of the bubble and to take actual scientific measurements. So thank you, enjoy your day.